Hello everyone. Today's problem is about Fibonacci sequence. It is one of the most common programs in computer science. It also depicts how simple problems can be quite deceiving and can turn quite complex if not implemented properly. For the sake of this problem here, we are going to see how it can be solved using a simple technique. But if you want to know more about Fibonacci sequence, please check out the link in the description below for my video which explains a Fibonacci sequence in much more depth. So now coming back to the problem, the function is quite simple. We are given the first two elements 0 and 1 and our job is to find the nth element, which is the sum of the previous two elements. Sounds pretty simple. Is it simple though? Technique-wise, yes, it's quite simple. We don't have to think a lot. All we have to do is add two numbers. Let's see how that works. Okay, let's play a game where you have to live an imaginary life. In this life, you have $0 initially, and then you met one person, and that gives you $1. According to the rule of this imaginary life, whenever you meet another person, your dollar just becomes the sum of the dollars you had the last two times. It just depends on how many people you meet in total. Are you thinking, how is this small amount of money going to make you rich? So let's think for a moment. How much money would you make if you met 10 people? You would have $55. Now imagine how much money you would make if you met 20 people. You would have $6,765. That's right. It's more than 100 times the money when you had met 10 more people. Now imagine if you met 30 people, that is just 10 more. How much would that be? You can't even guess it. It's a whopping 832,040. In your lifetime, if you're not a lazy person as I am and manage to meet 50 people, how much amount do you think you will make? 1, 2, 5. I can't even say it in words. I don't know what metrics to use. So now, bursting your bubble of having that much money and bringing you back to reality, it's quite fun to imagine if the rewards work that way. So other than the large numbers, what exactly is the problem with this function? For computers, it's harder to compute each time we call the value for large numbers. Imagine you're going to every single person you had met previously to calculate the amount you should have. Sounds tedious, right? The same is the case for computers. It is easier to calculate if we have a few numbers, but it becomes more difficult as the numbers increase.
Damn, that felt good.
Let's look further in this problem statement and you will realize why it says it's an easy problem. The constraint is dependent on n, which is the nth number in the Fibonacci sequence, which makes the problem a lot easier even if it runs on some inefficient solutions. We had seen in the example what the value 30 amounts to. So let's look at one of the solutions. Looking at the code, we have to return the sum of two numbers dependent on the previous one. This is tedious if we have to do it again and again. So here we just make a dictionary to store our responses in that. We declare the first two values. We keep calculating the next values in the series till you reach nth value. Notice that here we take n plus 1 instead of n in the range function, because if we take n, we will just have n minus 1 as our last value. In the end, we just return the answer. Let's look at the time and the space complexity of the code. The solution is pretty straightforward and is completely dependent on the value of n for both the time and the space. So for both, the value would be O of Okay, that was it for today's problem. Thank you so much for watching the video. I hope you found the video useful. I also have another video on Fibonacci series which explains in depth the concepts about recursion and also memoization. If you want to know more about that, there are links in the description below to the problem statement and also the code and also the usual. Like and subscribe to my channel for more amazing content. Until we meet next time, keep asking questions, keep growing, keep coding.